Well, welcome to part 2 of our properties of parallelograms. In our last lesson we talked about the relationships between the sides and the angles in parallelograms, and we had several different theorems that we worked with to solve problems. In this lesson we're going to focus mostly on the diagonals of the parallelograms. And our first theorem says that if a quadrilateral is a parallelogram, then the diagonals of that parallelogram bisect each other. So here's a picture for you showing both pairs of opposite parallel sides. And if the diagonals bisect each other, what that means is these segments right here, AE and CE are congruent, and then also BE and DE are also congruent. So here's an example where we're going to go ahead and use that theorem to solve a system of linear equations to solve for both x and y. So we have parallelogram LM and K, and we want to know what are the lengths of KM and LN. So we're looking for the lengths of those two diagonals in the parallelogram. So first off, since we know that the diagonals bisect each other, we know these two things. We know KP is congruent to MP and LP is congruent to NP. So then what we want to do is go ahead and substitute in the algebraic expressions for those different variables. So the two equations that we can write are y plus 10 is equal to 2x minus 8 and x is equal to y plus 2. So we have two equations and two unknowns, so we should be able to go ahead and solve that system of equations, finding what x and y are equal to. And then once we know what x and y are, we can find the lengths of the diagonals. So first off, we already have x is solved for y, we have x is equal to y plus 2. So equation 2 is solved for x already. So what we're going to do is we're going to go ahead and just take the right-hand side of that equation and plug it into the first equation. So we're just taking that quantity y plus 2 and plugging it right in to the right-hand side there for x. And then we're going to go ahead and rewrite that equation. So this is equation 1. Y plus 10 is equal to 2 times. Now notice instead of x right here, we have y plus 2 right there. Okay? And so we just rewrite that with that quantity in there. Now we're just going to use a little bit of algebra. This is our distributive property. Multiplying 2 through your parentheses, we get 2y plus 4. And then rewrite your minus 8. And then the next step is just combining the plus 4 and the minus 8 to give us a negative 4. And then what we're going to do is we're going to subtract y from both sides, and we get 10 is equal to y minus 4. And lastly, we're going to add 4 to both sides, and we find y is equal to 14. Well, once you've solved for y, we have equation 2 tells us how to find what x is equal to. Equation 2 says x is equal to y plus 2, and if y is 14, that tells us that x has to be 16. Alright, so our last step here is to go ahead and figure out what the lengths of those two diagonals are. And if you look back up at the picture, diagonal KM is twice the length of KP. So if we can find KP, the whole thing is just double that. And likewise for LN, it's just double LP. So that's what we're going to go ahead and do, is we're going to find out, instead of KP, we're going to write its algebraic expression as y plus 10. But we found that y was 14, so we're going to do 2 times 14 plus 10. Which is 24 times 2, which is 48. And likewise for LN, LP is just x, and we found x was equal to 16, so that gives us a total of 32 for diagonal LN. Alright, here's one for you to try, very similar to the last one. Go ahead and pause the video, set up your system of two equations and two unknowns, and see if you can solve for x and y, and then find out what the lengths of the two diagonals PR and SO are equal to. Actually, that should say SQ. So go ahead and pause the video, try to solve those on your own, and I'll show you how to do that when you get back. Alright, hope you gave that a try. Here's what I came up with for my two equations and two unknowns. Your first equation is 3y minus 7 is equal to 2x. Second equation is y is equal to x plus 1. Notice we have the second equation is solved for y, so that's what we're going to want to substitute. We're going to take that x plus 1 and just put it into the first equation wherever there's a letter y. Okay, so when we do that, here's the substitution. 3 times the quantity x plus 1, and then rewrite the rest. Minus 7 equals 2x. Use your distributive property. That gives you the 3x plus 3 minus 7 equals 2x. The next thing you want to do is combine like terms. The plus 3 and minus 7 gives you a minus 4. And then subtract 2x from both sides. And we end up with x minus 4 is equal to 0. And our last step is to add 4 to both sides, giving us x equal to 4. And what you can do once you have x equal to 4 is go ahead and take that and put it into your second equation, where you have y is equal to x plus 1. So if x is 4, that means y is equal to 5. Now our last step, we want to know what the lengths of those diagonals are. So PR right here is actually equal to double 2x. So if you just say PR is equal to 2 times that segment TP, and that's 2x, that gives us 4x, but x was 4, so we know that PR is equal to 16. And then lastly, our second diagonal SQ, we're just going to say that's 2 times y, which is 2 times TQ segment right there. And y was equal to 5, so we get that diagonal is actually equal to 10. So the second part of this says, in problem 3, does it matter which variable that you solve for first, and explain your answer? And actually it does not matter which one you solve for. We could have taken the second equation right here and solved it for x, and we would have had y equal to x, or excuse me, x equal to y minus 1, and then just substituted that in for x instead of for y. And it really doesn't matter. You'll get the same solutions either way. But just try to make the algebra easy. Don't go through more steps than you need to. Since our second equation was already solved for a variable, just use the right-hand side to go ahead and solve for the other one. All right, your next theorem says if you have 3 or more parallel lines and they are cut by a transversal, and that transversal cuts your parallel lines into congruent segments, then the opposite transversal, or the second transversal that's over there, is also going to be cut into equal segments. So the picture is a lot easier to understand. So if we have AC and CE being congruent, then in the picture on the right-hand side, you can see that BD and DF will also be congruent. So here's how you're going to use that in an actual problem. It says in the figure we have 4 parallel lines this time, and they tell us that each of the segments AB, BC, and CD are equal to 2 units. They also tell us that in the second transversal, segment EF is 2.25 units, and they want to know what's the length of EH. What is the length of that segment? Well, because of the theorem above, we know that EF and FG and GH are all cut into equal segment lengths. So by using that theorem, we can just say, well, the total length of that segment EH is just the sum of each of those pieces, and each one is 2.25 units, giving us a total of 6.75 units. All right, here's your lesson check. Go ahead and work on these 2 problems and bring your answers to class, and we'll talk about those next time. See ya!